Hey everybody, this is Larry. This is week 3 of the Premium Leetcode Challenge weekly. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. Today we have 1580, put boxes into the warehouse too. I have not done this one, yay, I thought not, that's right. But yeah, you are given two arrays of positive integer boxes in warehouse, represent the height of some boxes of unit width and heights of and rooms in a warehouse respectively. The warehouse's rooms are labeled from 0 to n-1, left to right, where warehouse of I is the height of the ith room. Boxes are put in the warehouse by the following rules. Boxes cannot be stacked. You can rearrange the insertion order of the boxes. Boxes can be pushed to the warehouse from either side. If the height of some room in the warehouse is less than the height of a box, then the box will stop behind the room. Return the maximum number of boxes you can put in the warehouse. Okay, so you could put stuff from either side, but that really effectively means that you can only have two things, right? And you can insert them in any order. So you put yellow in room 2 from either the left or the right, then orange in room 3, green in room 1, right? Okay. This is a cute thinking problem. Okay, I mean, this is a cute thinking problem. So let me think about this. I don't have an immediate thing. I mean, I think my initial observation is just brute force in a way. I think basically the first observation that I would make is that given this warehouse thing, you basically treat it like brute force where the divide is, and then just greedy on the left and the right, right? What I mean by that is that, let's say in this warehouse, you split it between 1 and 2, then now you're solving two problems, and then just, solving them. And of course, the box heights are fungible, so it actually doesn't matter, right? And you get to skip them, as you can see from this illustration. You get to skip stuff, so it doesn't really matter that much. And you can also fit smaller boxes in bigger boxes or in bigger warehouse or whatever, right? So yeah, so that makes it, so that's an idea that I would have. So then that makes it so that you don't have to think about like left or right. And effectively, that's what happens anyway after you put in the first box. But that's how I would mentally think about it. Yeah. And this thing doesn't even matter because you would just never really, because you can't you get to choose the order, right? So this doesn't really apply. Wait, maybe I'm actually no, maybe I'm wrong about that one. If the height of someone less than the height of a box, no, I'm wrong about this one actually. Because for example, here you can never. On example 1, the warehouse 1, you can never get 5, right? That makes it actually, I mean, yeah. I mean, I think that doesn't matter. I mean, it matters in the sense that you have to do like a linear filter or something, but I don't think it matters that much, right? Because you can just take you can do like a filter going from left and then the right or in some way so that, yeah. Because effectively, let's say you break into half, so you only have halves, right? The left and the right, so that you only can come from one direction. And here, then now you just do a filter and then it's going to be longest or not, it's just going to be like monotonically, no, the other way. Monotonically decreasing into the middle, right? Because you can't fit a box that way. Okay. But now, okay. So let's say that's the case. Then how do I split it in a way that is easy, right? I don't know. 10 to the 5 is pretty big. I mean, okay. There are really two ways to think about this to begin with. Is it? I'm trying to think. So the idea about snapping it in half, that only works if you're able to kind of transfer the subproblems one at a time, like from like an incremental change from splitting, like almost like a scan line thing, right? You could make a subproblem that is from, you know, something, and then you change it to the other. But I don't know. This is kind of hard, isn't it? There's only a medium. Maybe I'm missing something still. This is a funky problem. Okay, I think the case, the way I would think about it is case analysis. So I think I have to bring it up. The drawing, and I'm trying. I don't have a good visualization in my head right now, to be honest. So I'm just trying to draw things out, and then see if I could get some visualization that way. So let's say I have this, right? So let's say I have something like this. And let's say we start with this as being the dividing line. So you go this way. And here in a greedy kind of way, you do the orange box here, the green box here, oops, the green box here. I guess actually, one way that I would think about this is also that you can be greedy about this, right? In the sense that you don't always have to match them perfectly. You can always just be greedy going from left to right. And I think that may actually give you an approximation. But in any case, okay, so then let's say you move this line to here. So we have to be able to do incremental change. And here, the thing is that, I mean, it doesn't show up here, but what if there was a way such that, for example, if we have two of these three ones, then in theory we want to remove this one, move it here, and then fit this one with 3, right? How do I do that in good time? And if we're greedy, do we do it that way? I don't know. It's very unclear to me how to do it, how to get it. And then now, let's say we move another one. This thing does nothing because nothing can fit here. And then let's say we move another one, right? And then now, well, this will definitely give you a worse result in this one because in a way, you cannot go past the 1. So then now, yeah, I don't know. I mean, I don't really have a good generalization about this one though. Like, I mean, am I missing something weird? And also, I think I mean, I think there is some sorting because we always. I think one idea that I would make is that you always want to get the smallest boxes first, because let's say there is a case where, yeah, I think you always want to do the smaller boxes because, in a greedy way, it doesn't make sense to care about the bigger boxes. For example, if you have something like, like this is height 1, right? Oops. This is height 1. Like, let's say this is the thing. You have height 1, and then it doesn't matter what everything is in between. But if you have two height 1s, then you know you would fit all the 1s in between anyway, right? I think so. The first thing that I would do is sort the warehouse boxes, because that, no matter what the results are, or no matter what the optimal is, that is the optimal way to insert them. Because and in a greedy way, right? And the greedy proof for always doing that sort is because of the exchange argument. If you exchange a box that is height 3 for a box of that height 4 in a very obvious kind of way, and that's not the exchange argument, I guess, but in a obvious kind of way, that can only give, like, there's no way for a bigger box in the order to give you a better solution because of the way, because of that key observation 3 about the box not going through, right? So then now that means that from the lowest point, if there are multiple lowest points, okay. So then now we're thinking about the warehouses, right? And I'm just thinking through the cases. If there are multiple, if there's only one lowest point, then we always just start with that as the first block, and then fill on the left and the right as necessary. And I think you could do it in a greedy way, because and the way that you can prove that is greedy is right, because I think it's case analysis, right? Because either it fits perfectly, and if it fits perfectly, no other thing's going to fit more perfectly. And if there's two things to choose, you choose the one that is bigger. Oh, sorry, you choose the one that's small, the warehouse that is smaller, because it fits more perfectly, because it's also the greedy argument. And then you use induction on that. Okay, so that's if there's only one thing, right? So that's a proof-ish. Another proof is if there are two things, kind of like this one, then it doesn't matter which one you begin with, I want to argue, because then now you could draw a line between them, and you just all, and then now you have many, many, many of those things, right? So that means that you get the lowest point, and then now this is going to be, and then with I mean, you could do it in some way, but that's not, I don't, I feel like that this makes it a hard problem, but not a hard problem, but just like there's so many steps, and I feel like there's an easier way to do it probably. But the way that I would do it is like a pre-filtering the things from the smallest point, and then now from the smallest point it just becomes you know, that mono stack thing of like, okay, what is the next thing that is smaller than, so for example, this is height 2, then what's the next thing that is smaller on the right side? And this is going to be 1, so then you update this to 1 and so forth, right? So you can filter it that way. And then now you replace all these with 1s, and then this is, everything else is just going to be monotonically increasing, and then you could run the algorithm. Seems kind of hard to kind of make up, but I don't know, maybe I just don't have any ideas, so maybe that'll have to be good enough. Okay, fine. So boxes we can sort. That's like we said, greedy should make sense here. And then warehouse, we want to get the lowest point, and that would be our entry point for the middle box, right? So yeah. Yeah, okay. Uh, 10 to the 9, so yeah, I'm lazy. I think you could do something like warehouse, min of warehouse, lowest is equal to this, and then lowest index is equal to. I think actually the way that I said about mono stack, it's not even necessary, right? I can just, I feel like there's like a, I mean, I guess there's a dot find or dot index of the lowest or something like this. But then, but I want to get all of them, right? So here maybe I'll just write index is equal to right? And then for I in range of n or w for warehouse, say. Oops. If warehouse of I is equal to lowest, then indexes dot append I, and then I kind of even wrote this in a funky way. There's something like on my monitor, but because then now you can write for I in range from indexes of 0 to indexes of the last one. So you don't even need a full array for this really, but then now warehouse sub I is equal to the lowest, right? This is +1, because this is just what we said, right? Because if you have two things, nothing can get in between. And then now we can run the algorithm of running it monotonically increasing. I guess I still need to write that algorithm, right? So it doesn't even matter. Yeah, I guess I don't even need to do it this way. It doesn't even matter. So then now we just do lowest index is equal to warehouse dot index of lowest, right? And then now we run make the warehouse monotonically increasing from to the left and right from lowest index, right? So then now we just say yeah, right? So let's just say to the right first. So then now we have for I in range of lowest index to n or w. Why did I remove that one? Didn't I have it? Huh, I don't know. That's very weird. Right, maybe you have a stack, and the stack is going to be yeah. So while length of stack is greater than 0, and the top of the stack is greater. Is it greater than? No, it's lower than, right? So if this is lower than warehouse sub I, then we want to pop it, kind of. But before that, we have stack of zeros of 1. I mean, it is kind of right, but we have to update stuff. But I think that's fine. I think we can update based on the final results. So we pop. Yeah, we can update on the final results. It's a little bit wonky, but I think this is fine. Yeah, and then stack.append warehouse sub I. Oops, warehouse sub I, and then I. As to index, right? Let's print it out real quick, just make sure I didn't have any silly errors. 2. Am I looking at the right one? Okay, I guess this is right. Oh, this is what we expect. Here it should also be 2, 3, 5, 4. Kind of right, but I expected to. Oh, wait, what? This. Oh, no. I'm confusing it because there are 2 things. But this is wrong. This is if the warehouse is. No, it should be this way. Because if warehouse is lower, then you remove it, because then you get that monotonically increase. There we go. That feels more right. I'm so bad at this. Yeah. So then 2 index 3, that's right. Okay. This is starting from 1, 1. Second 3. Okay, yeah. This is what I expect. This is why I have to. This is why we check it incrementally, right? And then now we can say. Yeah, and then now we want to fill things in the middle. Though here does not have a good, neither of these cases does that. So we need to create a new case. The boxes, it doesn't matter. Let's just say all ones, just for science. And then now we have maybe 2, 1, 5, 4, 3, 1, 2, 3. So in theory, this should, all throw out to be ones. That's what we want, right? I got rid of printing the stack. That's why I was confused. Yeah. Now 1 is 1, and you have 5. This is very well because the. Oh! I always get this wrong. It's like in a weird typo kind of way. There we go. And this is why we double check things. But yeah, I always. I think because I confuse Q's in my head. I mean, I know what they are. It's just that, like, implementation wise, I always put -1. I wish. I mean, I think it's a Pythonic syntax thing because in other languages like Q, you could pop left, and stack you just pop to show the front or peak or something like this. And there's no ambiguity. Where here we have to do indexing, which is a little bit awkward for Larry. But in any case, yeah. So index 5, this is 1, this is what we expect, right? Okay, good. And then now we do something like, we do a zip on the stack so that we can, yeah, fill things out. Yeah. Trying to think. I was just trying to think whether the last object is always on the stack, and I guess it always should be by definition of this, and there's nothing afterwards. But yeah. Yeah. So then now you have this. We don't. Do we care about the object? I guess we do care about the object. We don't care about the first one. We want to go, this is the previous index, this is the current index, and then this is the height of that. So then now, so the reason why we could fill it in, it's not really a big deal, but I think it just makes the problem a little bit easier for me to think about. So then now for I in range from previous to current, and this is previous plus 1. Was it warehouse sub I is equal to H, right? So then now we can print warehouse again, and you can see that basically it flattens everything in the middle and to the right. Okay. Yeah, and we could. My is that we could probably do something to the left, but it's just very weird to do the indexing. I guess we can do it. because it is symmetric, so we could reverse everything if we really wanted to. But let's just write it again. Then to the left. I don't know if that's true though. Maybe this is a little bit less ideal. Anyway, -1, -1. This stuff is fine though. And then now, yeah, but now this is in reverse, so you actually want to go from current. This one is good previous. And we want to just double check this because I am really bad today apparently. So we want this, and then maybe we don't need a thing. We just do say this is 3, and it should be 3 out on the bottom. Oh, it should be 2 out apparently. I didn't even notice. So the code is more correct than I am, which is good. Okay, good. And then now we can do our greedy thing of starting from the lowest index, right? So here we will just basically go left and right? So so let's just say left is equal to right is equal to lowest index, right? I guess maybe not. Maybe we can do this way, but yeah, and then I'm trying to think how to think about this. It's a little bit awkward. And user 0, 0, right? So then now here, because boxes is already sorted, maybe we can, I don't know why I do this. Maybe I can just write in boxes. Right, and this part is pretty straightforward. If warehouse of lowest index is if it's greater than or equal to box, or not lowest index, whoops, left or right, then left we subtract 1, used we continue, right? And then same thing, we can just do if, oh no, we want to be greedy, right? So here we go, m is equal to min of warehouse of left, warehouse of right, right? If min is greater than or equal to box, then we increment by 1, right? No, this isn't quite right because we always want to use the box. This isn't quite right either. Hang on. Maybe something like this, but then now I think we have to do something a little bit better, which is okay. I mean, I think I try to be too clever. Maybe we just need some case analysis, which is that if warehouse of left is greater than equal to box and warehouse of right is greater than equal to box, then just do greedy, which is that if warehouse of left is greater than or equal to warehouse of right, then we move to the right. And then else, but there is one weird case here, which is that if the first box is a little bit weird, maybe I have to handle the boxes that way. This is so weird. Okay, maybe I just need to handle the first box, whatever, right? So if boxes sub 0 is less than or equal to warehouse of lowest index, because this is the only way that'll fit, right? If it doesn't fit, then it doesn't fit anything. If this is the case, then we used one of the boxes, and then boxes, I'm going to write this in a lazy way, which is we move the first object. But we only do it once, so it's fine, I guess. And then now we can do this. Yeah. Oh, well, we can do this, but then now we do left increment 1, right. I think this should be the case anyway. So, maybe this is a little bit. But we have to be. This is so annoying to write. I think I'm just writing it poorly. I don't even think that, like, because the thing is that now you have to check on the indexes and stuff like that, right? Like if left is greater than you go to 0 and right is less than n. Otherwise, if left is greater than 0 and right and warehouse sub left is greater than you go to box, then I don't know what happened to this number here. If right and warehouse. Right, so only one of these. So if only this is if both of the cases are true, then we take the smaller one. Here, if only one of these are true, then well, we take whichever is true. And then now we cannot do either one. So if we cannot do either one, then we move from the one that is smaller, right? Also, this is just wrong, obviously. If they're the same, it doesn't matter, I guess. We want to remove the one that is smaller to go to the right, because that means that nothing in the future will fit anyway, right? I think I have to write it in a different way. I don't know if I'm writing this in the best way. And then otherwise, if left is greater than 0, that means that one of these two conditions is not true. So then if this is true, then we go to 1. If right is I think this has to be true, but maybe not. And then otherwise we have no more boxes, so we just break. And at the end we just return used. I don't know, I feel like I really complicated this particular one. But apparently we still have an out-index and index issue. Oh, this should be W because it's warehouse, not N. For boxes or whatever. I forget which one's which. Alright, there we go. Let's give it a submit. Hopefully no silly mistakes. Oh no. That wasn't an input, right? Because I thought we had it. Okay. So why is this wrong? Expected 4, we got 3. So warehouse we have 5 for 1, and then it goes up, right? So I think warehouse doesn't even change. Let me double check. Like on the filter, I think it should stay the same, which is true. So then now it tries to fit the 1, and it does. It should. It tries to fit the other one, which it should, and then a 4, and then the 5. Why does it only do 3? Let's see. This should not break at all, so I think I could rewrite this in a cleaner way. I just have an idea, but in either case, we don't have to really. I don't know if this is true. Well, like I don't know what this is for, but There's so many early continues that that's not useful. Okay, let's try here. So we should do it 1144. So, oh no, this is a different 1144, I suppose. Yeah. So the first box is already filled. So you have 1, 1, 1, 4. So this first 4 does not fill. And this makes sense. I actually have a bug. This is not supposed to be whatever. There should be a. I thought about this, but then I wrote it incorrectly. So when this is used, this is good. But then when it's not used, I have to keep checking, right? So this is a while statement. How do I write that? Maybe something like that. Right? Otherwise, we do this and then we keep going. Maybe this works. Hopefully not break. Okay. Yeah, let's give it a submit. A little bit lazy to double check. Oh no. Why am I so bad? I mean, I think that the previous wrong answer was very legit. I thought about that case and then I just forgot about it. This is what happens when you don't have enough focus, I think. Like I did actually thought about that case. Because I was trying to rewrite it, so because that I think I even began to rewrite it, but then I just forgot about it, which is very bad. Okay, so this is the warehouse. It starts at 1, and then okay. I mean, I think this is the right warehouse. So then now it thinks. Right, what is the boxes? After it's sorted. There's 4 and 6. So this one, it. Oh, did I do this wrong? So it starts at 6. Oh. Okay, I see. I'm wrong here. Because so this tie breaking is wrong. Because if this is the case, then we're good. But okay, I think I got it. But I can't do it this way. So the reason why this is breaking is because we put the where's the thing? We put the 4 in. We put the 4 into the 6 because that's where we start on the left side, and then we just kind of skip ahead. But the point here is that if your first box is a 4, and here you're seeing that you have all the sets of 1s and 2s, it cannot be possible anyway. So you need to eliminate them. So okay, maybe I could rewrite. Maybe this makes it cleaner actually. So then now we can do something like while left is greater than 0, and warehouse of left is less than box. That means that it's never going to be used because in the future it can only be whatever, right? So we write something like this: while right is less than W, and warehouse of right is less than box. We do right, right? So then now we can just do this thing, right? Where if they're both into consideration, then we can just do greedy. This actually makes it cleaner as well. If only one of the consideration, then okay. So you don't need this anymore. Oh man. Though this is no longer a brick, I think. Again, we have to change it back to continue. Okay. That makes sense. Actually also makes the code a lot cleaner, or ideally. But because the idea here is kind of like a weird merge sort-y things. So, I mean, I think the idea is okay, but I mean, the implementation is fine after a little bit of silliness, and I just didn't really have a clear idea. I mean, I had the idea, but I didn't think about how the edge cases get shaken out, and that really took a long time. I'm curious if there's a better way to put it. Add smallest boxes to rightmost rooms from both ends. I don't know what that means. Approach to add largest possible box from both ends. I guess both of them are kind of the way that I thought about it. But I don't know how they handle. Am I just being funky? I get what they're trying to do. But how do they care about like the dips? I think that's the thing that I don't understand. I guess I see how they do it, but that's a very funky filter actually. The reason why this works is because if you are like if you see a dip, then it eliminates all the boxes that are bigger than it. That is a clever way of thinking about it, I think. Well, I spent like half an hour on this or longer maybe. I mean, I think the filter is fine. This isn't that. I mean, I don't know. Like I think this is not an easy technique to think about, but the other one is even harder because I think it requires like a very tricky proof. I think this one was fine. I had some like weird edge case issues about not thinking about it precisely, but the idea is fine. I think. I don't know. Anyway, I mean, this is going to be dominated by the n log n. Everything else is linear. So it should be pretty good. N log n plus n plus w, I think is the complexity. Yeah, and that's all I have for this one. Here's the first half of the code. Here's the second half. I don't know how I feel about this one. Yeah. Anyway, stay good, stay healthy, to good mental health. I'm going to get some rest. I'll see you out later and take care. Bye-bye.